Good day. My name is Joshua Franz Osayta from Bicol University College of Agriculture and Forestry, taking a BSABE. So today we are going to solve a problem under the chapter Equilibrium. And this is an equilibrium of non-concurrent force system. So this is from the book Ferdinand Singer, Engineering Mechanics 3rd edition. So our problem is a pulley of 1 feet radius supporting a load of 500 pounds is mounted at P on a beam horizontal as shown in figure P-3-5.15. If the beam weighs 200 pounds and the pulley weighs 50 pounds, find the hinge force at C. So this is the figure that we are going to solve. This figure is a pulley problem, and it is under the equilibrium of non-concurrent force system. So the first thing that I will do, the first step that I would do is to write the given and the required. So here, this problem, the given is the radius, which is equal to 1 feet, the weight of the load, which is equal to 500 pounds, weight of the beam, which is equal to 200 pounds, the weight of the pulley, which is 50 pounds. So the next one is the required. Our required is the reaction at C, or the hinge force at C. The second step is drawing a free body diagram. A free body diagram helps you to determine the forces acting on the system. So at point A, notice that we have a roller support. A roller support always has a reaction perpendicular to the plane. So since in this case, we have a horizontal plane, therefore we have a vertical reaction force at A. So it is perpendicular to the horizontal plane. So we assume that the reaction at force at point A is pointing upward. So no worries, because our solution will correct us if our assumption is wrong. So at we proceed to point C, notice that at point C, we have a hinge support. A hinge supports a forces horizontal and vertical. So also, just like the reaction at point A, we also assume that it is pointing upward, and we assume that the horizontal reaction at C is pointing towards right. So we have another force at the center of the beam, which is the weight of the beam. So we can calculate for the distance of the beam from A to the center, which is 2.5. So we divided the full length of the beam by 2. So another one is the weight of the pulley, which is equal to 50 pounds. It is at the center of the pulley. And then we have a weight load, which is equal to 500 pounds. So we have a radius here of 1 feet. We have a radius here 1 feet, and its distance from the rim of the beam, the rim of the pulley to point C is 1 feet also. So we have another force here, which is the tension force, and it has a slope triangle of 3, 4, 5. So it is a 3, 4, 5 triangle because if we square root the 4 squared plus 3 squared, we will have a answer of 5. And then it is equal to 500 pounds. It is equal to 500 pounds because we neglected the friction at the rim of the pulley. So notice that our tension force has a horizontal and vertical component because it is a inclined force. So the next one is, so notice that we can modify this free body diagram because the forces acting on the pulley will have an external effect on the system. So therefore, we can remove the pulley and shift the tensile force and the load of the weight to the center pin. of the pulley. So how can we do this? So I have an example here. So a beam and a pulley is attached to the tip with a center pin. So notice that these two tension force is equal, and its line of action doesn't touch the center pin or at point A. And also this vertical tension force here, also its line of action doesn't pass through the point A. So therefore, we can add a moment here to make it equal or to make it equilibrium. So we have here, so let's call this M1, and notice that the moment equation is force times distance. So our sign convention here is we are taking a clockwise moment to be positive. So therefore, our moment equation is m is equal to force times distance. So our force here is the tension force. So we will start here at the tension force that is inclined. So we have the force, which is the tension, times its distance. So its distance is the radius. So here is the radius. So we have a distance r. Then since it is a since that we have a side convention which is clockwise to be positive, so this will have a moment that is counterclockwise. So we will have a counterclockwise moment which is negative. So here, the vertical tension, we will also have an equation here which is M2. So M2. So it is also equal to, since it is T, so we have our force here, force T, and its perpendicular distance, which is R. So we have a perpendicular distance R, and notice that it will turn clockwise. Therefore, it is positive. And when we summate the moment at point A, notice that we will have a zero moment because they will cancel each other. So therefore, this will be equal to this, to the figure to the right side. So there. So since that we have a basic knowledge about this concept, so shifting the two forces in summary, T and W to the center pin. So the number one step is keep the direction and the magnitude of the force. So just like here, we kept the magnitude and the direction of the force T, and then the second one is add a couple, just like what we did here. So M1 and M2. So they will cancel out, then it will equal to 0. Therefore, we will now have a modified free body diagram. So here is the modified free body diagram. So we shifted the tension force and the weight of the load to the center pin. So here is the center pin of the pulley. So when we shift that, so we added the distance of the center pin to the rim, and then to the rim, and the distance to the rim to point C. So we added the distance here because we will have no force here. So therefore, we will have a simpler equation or simpler solution. So the next step is resolving the component of the tension force. So we have here the tension H or the tension horizontal. So the tension horizontal, its relation to the trigonometric identity is the opposite over hypotenuse, which is the sine theta. So, sine theta in relationship to the trigonometric identity, sine theta is equal to opposite over hypotenuse. So, therefore, we can use this slope triangle. So, when we are using the slope triangle, so we can use the trigonometric identity. So here, since we have a sine theta is equal to opposite over hypotenuse. So our opposite in the slope triangle is 4 and our hypotenuse is 5. So therefore, it is equal to this equation. So 500 pound is equal to 4 over 5, opposite over hypotenuse. So the next one is tension V or tension vertical. Tension vertical, its relationship to the trigonometric identity is the cosine theta. So cosine theta is equal to opposite over hypotenuse. So just like the tension horizontal, so we can use the slope triangle. So cosine is equal to adjacent over hypotenuse. So therefore, our adjacent here is 3. So therefore, our hypotenuse is 5. Then notice that this will also be equal to 500 pound times 3 over 5. So the next one is using the equilibrium equations or equilibrium conditions. So the first one is the summation of forces vertical is equal to 0. The second one is the summation of forces horizontal is equal to 0. And the summation of the moment is equal to 0. So uh, since that we have a horizontal and vertical forces is equal to 0, therefore our R is also equal to 0. So at the first step is to summate the forces horizontal. So summation of the forces horizontal is equal to 0. Taking up forces to the right is equal to positive. So there we have a positive forces to the right. So we summated the forces horizontal because notice that we only have two horizontal forces. So which is the TH and the reaction at C horizontal. So we have a negative TH because it is pointing towards left. So therefore we will have a negative TH. And we will have a positive RCH or positive reaction at C horizontal is positive. So because it is pointing towards to the right. So we assume that this is pointing to the right. So there. So therefore, substituting the TH, the value of TH, and we have negative 500 pound quantity 4 over 5 plus RCH, which is the unknown. So it is equal now to 0. So simplifying, we have negative 400 pound plus RCH, and it is equal to 0. So we can transpose the 400, therefore we will have a positive reaction at C horizontal. So therefore it means that our assumption at C is correct. So the next one is uh, summating the forces vertical. So summation of the forces vertical is equal to 0, taking upward forces to be positive. So we have here the summation of forces vertical is equal to RA or reaction at A plus tension vertical plus reaction at C vertical. So this three is positive because notice that they are pointing upward. They are pointing upward, and then the next one is minus negative weight of the pulley or minus weight of the pulley minus weight of the beam minus weight of the load. So they are negative because they are pointing downwards. So therefore, um, we have now, it is equal now to RA plus 500 pound 3 over 5, which is the tension of the vertical component of the tension force, plus the reaction at C vertical minus 50 pounds, which is the weight of the pulley, and then the weight of the beam, which is 200 pounds, minus the weight load, or the weight of the load, which is equal to 500 pounds. So simplifying, we now have RA plus RCV, which is the reaction at C vertical, minus 450 pounds, and it is equal to 0. So since it is equal to 0, we can transpose the 450 pounds. So therefore, we will have a 450 pound equal to RA plus the reaction at C vertical. And this is our equation number 1. So therefore, we can now summate the moment at point C. But notice that I've been using this as my reference. So I've been using this as my reference, which is the TH and TV, and then the equilibrium conditions as my reference, because so that I will not be confused on what to substitute to the value TH and TV. Then we can also summate the moment at point C. Therefore, summation of moment at point C is equal to 0. So, taking up counterclockwise moment to be positive. So, therefore, summation of moment about C is equal to the weight of the load times the perpendicular distance about C, which is equal to 2 feet, or perpendicular distance about C. Then, plus the weight of the pulley, which is uh, 50 pounds, and then times its perpendicular distance about C, which is also 2 feet, plus the weight of the beam times its perpendicular distance about C, which is equal to 2.5 feet. So notice that these are all positive because this will cause a counterclockwise moment. So therefore, it will be positive. Then, minus the tension vertical times its perpendicular distance about C, which is also 2 feet, minus the reaction at A times its perpendicular distance about C, which is 5. Then notice that this will cause a clockwise moment. Counterclockwise moment. So therefore, this will be negative. So this is negative. Therefore, substituting the values, we now have 500 pound times its perpendicular distance from C is equal to 2 feet, plus 50 pounds times its perpendicular distance about C, which is also 2 feet, plus 200 times 2.5 times its perpendicular distance about C, minus 500 pounds times 3 over 5 times its perpendicular distance about C, minus the reaction at A times its perpendicular distance about C. So simplifying, we will now have 1,000 feet-pound minus the reaction at A times its perpendicular distance about C. So notice that it is equal to 0 because it is in equilibrium. Therefore, we can now transpose the reaction at A times its perpendicular distance about C. So therefore, dividing both sides by 5 feet, we can now cancel this, and then we can now cancel the feet. Then 1,000 over 5 is equal to 200 pounds. So notice that our answer is positive. Therefore, our assumption at A is correct. It is correct because our answer is positive. So it will be negative if and only if our answer here is negative. So another one is we will now compute uh, the reaction at C vertical. So from equation 1 earlier in this presentation, this is our equation 1. So 450 pound is equal to RA plus the reaction at C vertical. So therefore, substituting our answer, RA is equal to 200 pound. So we have now 450 pound is equal to 200 pound plus the reaction at C vertical. So transposing the reaction at A to isolate the reaction at V, I mean the reaction at C vertical. So we will have now 450 minus 200. Therefore, our RCV or the reaction at C vertical is equal to positive 250 pounds. So notice also that our answer is positive. Therefore, our assumption of the direction of the reaction at C vertical is correct because it is positive, because it is pointing upward. And now, we can now solve for our reaction at C. So, by using the formula, RC is equal to the square root of the reaction at C vertical squared plus the reaction at C horizontal squared. Then we substitute the values of the reaction at C vertical and the reaction at C horizontal. Therefore, we will have now RC is equal to the square root of 250 squared plus 400 squared. Then our answer now is RC is equal to 471.699. Therefore, it is pointing upward to the right. It is pointing upward to the right. And then, since we have the vertical and horizontal component, we can now solve for its angle or angle of the direction. So, our equation is tangent beta is equal to RCV over RCH. So, reaction at C vertical over reaction at C horizontal. So, we will now use the arctangent. So, therefore, beta is equal to arctangent times arctangent of RCV over RCH. And then, we substitute its values. Therefore, B is equal to arctangent of 250 over 400. Therefore, our beta is equal to 32 degrees. Therefore, this is now our reaction at C, which is equal to 471,699 pounds. And then its angle, which is beta, is equal to 32 degrees. So, thanks for watching and have a nice day. So again, I am Joshua Franz Osayta from Bicol University College of Agriculture and Forestry 2 ABE1. Thank you for watching. Good day.